So in this video, we're going to look at a few examples of how we can apply the properties of exponents if we are asked to simplify. And normally, if an expression is simplified, you only have positive exponents. So we'll try to keep that in mind as we go through a few examples. We are not going to work all of these, but I will do enough to give you an idea of how to go about solving each type. And then, of course, you will get plenty of practice on your homework and on future assessments. So let's look at problem number one. On problem number one, notice that we have a dot here in the middle. That means we are multiplying. That's what this symbol here means, multiply. And I wish that over the years when I taught students that I had done a better job at emphasizing that you really have to pay attention to the symbols and make sure that you are obeying exactly what the symbols tell you to do, because if you don't know what you're supposed to do from the beginning, how can you get the right answer? And so think about each problem as you move and look at, are you being asked to add, subtract, multiply, or divide? And again, since there's a dot there, we know we're multiplying. And I'm going to start off by multiplying 2 times 2, and that's going to give me 4. And then I have two expressions here, and they have the same base. Both of those have base m, and we learned from the laws of exponents that you keep your base and you have to add your exponents together if you're multiplying. And then, of course, 3 plus 2 is 5. So the simplified answer is going to be 4 times m to the power of 5. Let's look at problem number 3. On problem number 3, again, we're multiplying. So I'm going to multiply 4 times 2, and that would give me 8. And then I'm going to multiply these two together because they have the same base. Both of those are base r. So I keep the base, and I have to add the exponents. And negative 3 plus 2 is negative 1, right? Negative 3 plus 2 is negative 1. And we have to go back and look at the directions, right? Only positive exponents. And I don't think I really touched on this rule during the beginning, during my slideshow, but I do think that in the videos, they did emphasize how to handle negative exponents. But just in case, let me give you the rule here. If you have x to the power of negative m, then you may write that as 1 over x to the power of positive m. And of course, in this problem, the variable is r, but that doesn't change the rule. And I'm going to keep the 8 because the 8 technically has a power of 1. It's already positive, so it's going to stay in the top. And I will just take the r to the power of negative 1 to the denominator, and that leaves me r to the power of positive 1 in the bottom. So this is the simplified answer here. And by the way, we know that r cannot be 0, right? Because you cannot divide by 0. R cannot be 0. Let's take a look at number 5. On number 5, again, we're multiplying. So I'm going to multiply 2 times 4, which would give me 8. And since these two expressions have the same base, I'm going to keep the base, which is k, and I will add the exponents together. Don't forget that there is an understood 1 here. So that leaves me 4 plus 1 when I add those exponents, and that would give me 5. 4 plus 1 is 5. What about number 7? If you look at number 7, I can multiply 2 times 3 and get 6, but that's all I can really do. In other words, this x is the only expression that has a base of x, so I can just keep that as it is in the problem. And then y squared, well, y squared is the only expression that has a base of y, so it cannot be multiplied by anything. And I'll just write it in the problem like this. In other words, the only thing I really had to simplify was multiplying 2 times 3. And let's look at problem number 9. On problem number 9, I can multiply the 4 times 3, which gives me 12. And then I'm going to go after the A's. I have an A base. And if I add the exponents, let's see, a to the power of 3 multiplied by a to the power of -4, I will have to add those exponents together. So 3 plus a -4 is -1. And then I'm going to do the same thing with my base B. And since we're multiplying here, I will add those exponents. So that gives me 2 minus 3. Well, 2 minus 3 is also -1. And again, we do not want negative exponents. So what do? We follow this rule here, right? We take it from the numerator of the fraction to the denominator, and that will make the exponents positive. Now 12 already has a power of 1. It's not written, but it's understood. So I'm going to leave the 12 alone. And I will just move the a to the power of -1 to the bottom, and that will make it a to the power of +1, which I don't have to write, it's understood. And then b to the power of -1, that will also go to the denominator, and that leaves me b to the power of +1. And of course, a and b can neither of those can be 0. What about number 11? Number 11, let me erase some of this and move the page down a little bit. Of course, if you need to rewind the video, you can do that. Problem number 11, we're going to keep in mind that any expression raised to the power of 0 is 1. And if we look at number 13, if you remember PEMDAS, right? Please excuse my dear Aunt Sally says that you always start inside parentheses before you address the exponent. So let's go inside parentheses here. Notice that I have 4 to the power of 0. And 4 to the power of 0 is just 1. So that's really 4 times 1. So that leaves me 4 to the power of 4. And I could leave that, or I could simplify it if it's not too big, or maybe if I have a calculator. So 4 times 4 is 16, times 4 is 64, and I think the next would be 256. Moving on to number 15. On problem 15, notice that I have a 4 here that's on the outside of the parentheses, and that means this 4 affects everything inside. Everything on the inside is affected by that exponent. So let's keep that in mind. Remember, we technically have a 1 here, right? 3 to the power of 1. And remember, the rule says that if you have a power raised to a power, you just multiply. You keep your base and you multiply those exponents together like this. So let's do that. That's going to be 3 to the power of 1 times 4, and 1 times 4 is 4. So that's 3 to the power of 4. And then I have k, and again, this is a power to a power, and 4 times 4 is 16. Technically, that is simplified. We have no negative exponents, but 3 times 3 is 9, and 9 times 3 is 27, and 27 times 3 is 81. So I'm going to write 3 to the power of 4 is 81, and I'll just keep the k to the power of 16 there. Okay. Let's look at 17, and then after that we'll look at a couple of, I guess, a little more sophisticated problems, but let's do 17 first. Again, I've got, that was terrible. Let's clear that out and try again. I have an understood 1 here, right? 2 to the power of 1. And again, this is power to a power. So I just multiply, right? I multiply the exponents. So that's going to be 2 to the power of 1 times -1, which is -1. And then I have b to the power of 4 times -1, which is b to the power of -4. And remember, no negative exponents. So what do? Well, I create a fraction. I put a 1 in the top. And then I just slide the other 2 down and make the exponents positive. So that would be 2 to the power of +1, which is 2. And then I'll have b to the power of +4. Like that. Okay, let's move down and take a look at, say, number 25. On problem 25, let's see what we have here. We have a fraction, of course. I've got an understood 1 here. 3 divided by 1 is 3. And then I have m to the power of -4 divided by m to the power of 3. And since these bases are the same, I will keep the base and I will subtract top minus the bottom on the exponent. So that would be -4 minus 3. And -4 minus 3 more is -7. And to simplify this, I'm going to leave the 3 to the power of 1 on the top. And I'll just take m to the power of -7 to the denominator and make it m to the power of +7. Number 27. I know that x to the power of 0 is just 1. So that's just 1. And 4 times 1 is 4. And this 4 here will cancel this 4 out. And that just leaves me y to the power of -2 times z cubed divided by x. Well, x on the bottom already has a positive exponent, right? It has an understood 1, so it will stay there. And z to the power of 3 already has a positive exponent, so I will leave z to the power of 3 on the top, like that. That's a 3. And I'm going to take this y to the power of -2 to the bottom and make it y to the power of +2. And again, I still do not have my pen. I'm writing with a mouse. So my handwriting is somewhat terrible. We'll get through it. Hopefully that mouse will get here soon. So let's see what we have. We have a z to the power of 3 divided by xy squared, right? This is to the power of 2 here, so that's a 2. And last but not least, let's take a look at problem number 29 here. Notice I have 4/3, right? I have a 4/3. Well, there's nothing I can do to simplify 4/3, so it just stays in the problem. And let's see, so I've got a 4 in the top and a 3 on the bottom.
Miss Merrill.
And let's take care of the m's. Well, I have an m to the power of 4 divided by m to the power of 2, right? These bases are the same, so I can combine these into the same base, but since I'm dividing, I have to subtract the exponents. 4 minus 2 is 2.
Miss Merrill.
And now let's take care of the ends. And n to the power of 3 divided by n to the power of 2. I'm going to keep the base and subtract. 3 minus 2 is 1, so that's n to the power of 1. And let's see, p. p to the power of 3 divided by p to the power of 4. That's going to be p. And 3 minus 4 is -1, but we know that that's a no-no. We cannot have p to the power of -1 in the numerator. So I'm going to take p to the power of -1 out. And I will just move it down to the bottom and call it p to the power of +1, or just p. So that is the simplified answer for number 29. So hopefully that served as a good review of how to use the laws of exponents to simplify. And next we will look at how to use the laws of exponents in order to combine expressions, to multiply polynomials together. Thank you.